Hey guys, so in this video we're going to cover the concept of rational functions and how the factors in them affect the graphs. And it's going to be very similar to what we talked about last class about how we're looking for the quote-unquote zeros of the numerator and denominator. Except this time Except this time, we're going to have a graph to kind of compare our results with and kind of deepen our knowledge and see how these effects are happening. So just as last time, we're going to do the numerators of the top, or sorry, not the numerators of the top, the zeros of the top and the zeros of the bottom. Okay. So just kind of organizing them like this, and then I can go ahead and look for my x values within here that would make this go to 0. So that's going to be a positive 2 right there, and a negative 2 right there. That would be for my top, so I'll put a negative 2 and a positive 2. I just realized I wrote those backwards, but it doesn't make too much of a difference. And then for the bottom, I'm going to look at this one and I'm going to see, well, when x equals 0, that goes to 0. When x equals 5, that goes to 0. And when x equals negative 4, that goes to 0. So on the bottom, we're going to have 0, 5, and negative 4. Okay? So, now let's go ahead, and so the second part of this question, how do they relate to the graph? And this is something that you can see the connection, but there's so many levels to understand it and so much depth to why this is going on that I really encourage you to stop the video and maybe for 5 minutes or so just think about why this is happening and, how can we expect this and what if you adjusted it. But if you took these numbers, first for the top, this actually turns out to be what we expect, a negative 2. And remember, these are all x values, so it makes sense to look on the x-axis. So we see a negative 2 right there, and we see a positive 2 right there. So it makes sense that these are just going to be x-intercepts. Okay, so these are just x-intercepts, and that's actually kind of how we got to talking about polynomials is by looking for the x-intercepts, breaking them into factors and finding those. So now on the bottom we see 0, 5, and negative 4, and when we go to those numbers, we actually have some pretty interesting action happening. We notice that our graph is bending upwards or downwards as it approaches that point, and we get this dotted line that's put here by the graphing software. So I'll go ahead and tell you that dotted line is something we call an asymptote. And it's a number, it's designed to represent a value that we can never reach. So when we see that dotted line, realize it's not a part of the graph, but the actual part of the graph is traveling right alongside it, kind of like this. So we look at these and we realize that these are just kind of going to indicate asymptotes. AS, only one S in that. I saw where you were going with it, only one S. And then the silent P, the asymptote. Oh, wait. There's no H in it. Messed myself up with the silent P. There we go. ASMYP asymptote, I believe. Okay, check me on that. It could be wrong, but asymptote, this is what these come to represent. So they're kind of these spikes with dotted lines that define them as to where the graph cannot be, and the graph kind of spikes upwards or downwards when it approaches it, as we can see on various parts where there are asymptotes. And where are they located again? Just at these zeros of the bottom. Okay, let's go ahead and look at the next one. Alright, so same sort of deal. We can kind of run through it a little bit quicker. So on the top, I'm going to have 0, positive 6, and positive 2. Those will be my zeros of the top. And my zeros of the bottom I'm going to have a negative 6, 2x minus 3. So that's kind of a hard one. So I'm going to go back to my fundamentals and write that factor set equal to 0. Remember, we're looking for x values that bring it all to 0. Sorry, minus 3. We're looking for x values that will bring this to 0, so we can just set it equal to 0 and then find out what that would be. So we'll go ahead and add 3. 3 equals 2x. Divide to get rid of that multiplication of 2, and we end up with a x that equals 3 over 2, or 3 halves, or 1 and 1/2. So 3 and 1/2, 5 and 7. Okay, so hopefully, you remember what we talked about the last slide. So these are going to be our x-intercepts, so we can look for some x-intercepts. This one at 0 is a little bit hard to see, but we do kind of see it gradually going towards it and away from it, so we can put it right there. There's another one at positive 2, and again, kind of hard to see. We get some crazy action that's going on within these, and, we're going to understand why this crazy action happens, but, there is an intercept right there as it crosses that line, and likewise, this one's a little easier to see right at 6. Okay, those are our x-intercepts. We can even write it over here just to reinforce that idea. Okay, and then over here we are going to have our asymptotes. And asymptotes with only one s. Remember, we are in school. So we have negative 6. We have 3 over 2, which makes sense. It's about 1.5 right there. And then we have 5 and 7. Okay. All right, and those values describe our asymptotes. Okay. Now they get a little bit more difficult. So you notice before we had the luxury of having things that were pre-factored, right? They were already factored and easy to find the zeros of, but this time not so much. We're going to have to factor these, but luckily they are not too hard. They're just trinomials, quadratic trinomials. So we can go ahead and factor each one. So first, x squared minus 4x minus 5. Well, I can pretty easily see that if I use a box method on this, I'm going to get out, these two numbers need to add to negative 4, so I could do negative 5x and positive x. That would add up to my negative 4. That'd give me negative 5 over here, an x, and a 1. So this top part can factor to x minus 5 and x plus 1. Okay, now to factor this bottom part. So to factor this bottom part, we're going to have to take x cubed plus x squared minus 6x. So I immediately notice I have a GCF of x in each of these, so I'll factor out an x, and I'll get x squared plus x minus 6. So we can then go ahead and use another box, and you can kind of think, we have negative 6 that's being multiplied to an x squared up here. What numbers could add up to make that x but multiply to negative 6? Well, that could be a positive 3x and a negative 2x. And so we will get a negative 2 up there, a positive 3 there, and an x right there, meaning that this thing factors to an x along with x plus 3 and x plus 2. Okay, we want to go ahead and write all that stuff over here. So we have a x plus 3 and x plus 2. Okay? And then those are our factors. It's then pretty easy to see what our zeros of the top and the zeros of the bottom would be. The top would have a 5 and a -1. The bottom would have a 0, -3, and -2. Okay, and again, we see that interacting with the graph in the way that we get asymptotes from the bottom, and we get intercepts from the top. All right, and that intercept looks like it's right about here. Actually, well, I guess technically it is +5, but could have been mistaken as 6 just looking at the graph, but either way, we know to look for it. Okay? Alright, and so definitely notice this connection. Realize we're going to be using these things to sketch out graphs in the future. Alright, so another one. This one's a little bit harder to factor. So as we go through this, we can collect our terms over here. So this top one's not too hard. I notice I can immediately factor out an x. And in doing so, because there's only 2 terms, both of which had an x, that leaves it completely factored out, and once I factor that x out. Now this bottom one's going to be a little bit more complicated. We have 2x to the third minus 17x squared plus 20x plus 75. Okay, and if there's anything, right, if there's anything you should be thinking right now, it should be box. Because we are used to having 4 terms, and with those 4 terms, putting them into a box so we can factor it. Right, this should be one of your first instincts. It's a very good one to have, but the thing is, once you write this, you're going to realize that it doesn't always work. How are we going to find numbers that multiply with 17, 20, and 75? 17 is a prime number, so how's that going to work? It's not going to. So we actually want to get rid of the box. And we're going to have to use the other method, which would be synthetic division. Notice, when we can't do box, we should think about synthetic division. So now I'm faced with the dilemma of finding zeros up here. Right? Remember, I need zeros to do a synthetic division. And this problem didn't give me any. Well, this is where we need to start using our critical thinking skills. So I'll go ahead and start to set this up. And while I do this, I want you to think, how could we guess a potential zero for this polynomial? And if you're still not sure to it, before I give it away, I would go back into the video and notice, how could you find a zero by looking at this graph? What about the graph could tell you where we could have zeros? And the answer to that question is, remember, our bottom is going to relate to these asymptotes. And so if we see an asymptote, we know that, hey, there had to be a zero for that polynomial there. So I see one that kind of looks like -1.5 over here, and I see another one that looks like 5 over here. So I'm going to choose 5. It's a little bit easier of a number to work with. And so I'll start off synthetically dividing by 5, because I recognize that that should be a 0 based on the asymptotes on my graph. Okay, so we synthetically divide. 2 times 5 would be 10, minus 17 would be -7, times 5 would be -35, plus 20 would be -15, times 5 would be -75. And that's beautiful, because our remainder is 0, which means that it's evenly divided, and what we are left with is our x minus 5, and then a 2, a -7, -15. Remember to find the x values on those. We count up from the remainder, so constant x squared. And that's the polynomial that we get. Okay, so it looks beautiful, but we're not done yet. Notice this is still a trinomial that should be factored, we can go ahead and think about doing a box method, because at this point, if we have 3 terms and it is factorable, we should be able to use a box. So we'll do negative 15 right there, 2x squared. Now we got to figure out what went in those 2 spaces. Remember, the best way to do that is to use our x method. So we can do a times c, which would be negative 30, adding up to negative 7, which is b, that middle term. So 2 numbers that multiply to negative 30 but add to negative 7. What could they be? So pause and ponder, and then realize that we could use a negative 10 and a positive 3. So I'll write negative 10x, 3x. Everything's looking good. I'll go ahead and factor. I get a 3, a negative 5, a x, and a 2x. Check to see the multiplication makes sense, and it does. So I just get x minus 5. Another factor of x minus 5, so I could actually just write that squared. And 2x plus 3. Okay, so writing it all in our final answer, we get x minus 5, and we'll go ahead and just square it right there to save some room. And then we have 2x plus 3. Okay, and again, these asymptotes are relating to the zeros that we talked about over here. And then our x-intercepts from up here are relating to the zeros that we found up top. Okay? Alright, so now we're going to go ahead and use this knowledge in reverse. And now I want you to think of the graph that we have here and how we can maybe piece together a polynomial that embodies some of those features. So remember, the key concept here is that our x-intercepts are still doing the same thing. Nothing's really different about them. So up top we get our x-intercepts, and those are our natural zeros. And then on bottom, we're getting these things called asymptotes, or breaks in the graph. So we can look at this graph to find our asymptotes. We have an asymptote of negative 5. So negative 5. We also have an asymptote of, sorry, not negative 5, I meant positive 5. Negative 3 and negative 5. Okay, so on the bottom we could expect factors to create these zeros, so that would mean a factor of x minus 5, a factor of x plus 3, and a factor of x plus 5. And that's what our bottom could look like, right? It would have all those asymptotes. So now, what about our x-intercepts? So it's a little bit hard to see. I'm going to go ahead and use my advantage of technology to zoom in here. And I'm seeing zeros that kind of look like they are one right there. I mean, if you see it, it curves up ever so slightly. Looks like kind of one right there and one right there. So this is the part where, it's a little bit hard to tell from the graph. Whoop. Say this were a test, you would have a very clearly shown graph, or multiple answers would be accepted, or you could choose an answer that looks clearly right, or that could be right, or negate the ones that are clearly wrong. But for right now, I'm going to go with zeros. Sorry, skipped a step. Zeros on the top of 0 and let's say positive 3. In which case, those would make factors of x and x minus 3. Now, what if you disagree and you say, no, Mr. Zoyas, it crossed the x-intercept at 2? Well, that's great, right? If you do think it crosses at 2 and you can visually support that, well then that is grounds for you saying that your top actually had a 0 of 2, not 3. Our graphs aren't super clear, so we have to do the best with what we have. Okay? And very last one. We have the same deal here, except this time they look a little bit easier to identify. So we will go ahead And what's that one doing? Is that an x-intercept? I don't think it is. Again, you know, when you have these things on tests or, you know, on Desmos, you can really zoom in and see where your x-intercepts are happening. But so remember, the idea is that we have a fraction going on, and the top part of it represents our x-intercepts, and the bottom part represents our asymptotes. So knowing that, I'm just going to go straight from the graph to writing my factors. I see an asymptote of -5, so I'll write x plus 5. I see an asymptote of -2, so I'll write x plus 2. I see an asymptote of -1, so I'll write x plus 1. And then that's all the asymptotes I see. So it looks like we're good on that. And now for our zeros, I see some pretty clear zeros. One right there, one right there. And it looks like there isn't any other zeros right here. It's kind of hard to tell. Maybe it did cross at some point. But it does kind of look like it's just brushing up nicely against it. So it looks like these are only two x-intercepts. So for the top, we could expect a factor of x from that 0 intercept, and then a factor of x minus 3. Oops, sorry, x plus 3 for that -3 intercept. Okay, so that's all for today. Make sure you see that concept of x-intercepts being on the top and asymptotes being on the bottom, and really start to think about why that's happening. We are going to learn about those reasons, but for now we can just make the connection and get a faint idea of it. So I hope you guys have a great day. I'm sorry I'm not able to be there, but I hope this helps as much as it can. Bye.